Hello, my name is Yogesh Kumar. So this is my second paper review for distributed system and algorithm. So this paper is titled Themis. It is an AST-based log-free route synchronizing and sharing system for self-driving in edge computing environments. So the basic introduction of this paper is to have to solve the challenges in real-time route synchronization between the self-driving cars with itinerary sharing, scheduling in self-driving, reducing transmission cost between two distance, and to ensuring the data consistency between the systems among the self-driving cars. So to overcome these challenges, this solution stated by this paper is called Themis, a distributed system which uses edge computing architecture with partial replication concept and snapshot sharing and synchronization strategies. So the main objective of this paper is to evaluate the performance of partial replication in reducing data transmission to improve the responsiveness of distributed systems, and to analyze the snapshots strategy for reducing operation history overhead, and also to test the compression of conjugative operations for minimizing the transmission cost and to ensure the final consistency across the distributed sites. So previously, there are many challenges faced on other research solutions also. So the main issue faced by previous issue which overcome in this particular literature is the data synchronization issue between the distributed systems. So the maintaining the synchronization between multiple nodes while maintaining the significant network bandwidth is so limited. And also there is high transmission cost in between sharing the establishing the communication between distributed systems. So traditional systems synchronize all data points even if partial data is allowed and relevant, leading to excessive network congestion and delays. And the third one is inefficient operations. In many systems, redundant operations are synchronized unnecessarily, which means already shared or already communicated part of data is over communicated redundantly without having a control over synchronizing in between systems. Without improving the final system state, this is creating network traffic and consuming high network bandwidth. So last one is scalability. Scalability is always a challenge for a distributed system. So as the number of collaborating nodes increases, maintaining efficient synchronization becomes more difficult, and delays in data transmission increase in between the network bandwidth. So these problems were addressed in this particular literature by adapting a concept called AST. AST means address space transformation. It is an optimistic collaborative editing algorithm to ensure a real-time responsiveness while maintaining a consistency in between the network communication happens in between the distributed systems. So this approach is used in document collaboration system in real time, which has been adapted to the domain of route synchronization in self-driving cars in the Themis system over this literature. So how this optimization happens in Themis? Themis optimizes this particular challenge based on three concepts, which is partial replication. Only the subset of the data which is relevant and new in a active node will be shared to the distributed systems. Second one is snapshots. By storing the historical states of operation, this particular system avoids unnecessary calculations to further reduces the data transmission. Third one is compression. Compression of consecutive operations reduces the size of data being transmitted, which lowers the transmission cost and also increases the system efficiency by sending the needed data towards the distributed systems. So this system is constructed by two different concepts. As we say, this is particularly oriented on three different strategies for partial replication, snapshot strategy, and consecutive operation compression. And it has edge side nodes, which is the local nodes which shares the data towards the distributed system. And second one is cloud side system or node, cloud side nodes, which manages the data processing, routing, and overall synchronization. So the edge side computers were mostly the self-driving cars. So each self-driving cars over the route is called an edge here. So it sends its transmits the real-time data towards the cloud side system through the network channel which is constructed. So here for network channel communication, they use a WebSocket API to share the data in between. So this network has a bandwidth of nearly 5 Gbps network bandwidth. So the key feature of Themis is dynamic partial replication based on vehicle location. Each node will share the location of the node present over dynamic partial replication process towards the cloud systems. And also real-time route and operation synchronization happen in very efficient manner in by compressing the data into snapshots and share it to the distributed system or the cloud service. And they use the Baidu Map API, which is popular in China, to implement the route management for self-driving vehicles. So they constructed this particular simulation in a single system. They simulated the edge nodes and the cloud server APIs in same computer. So they implemented two algorithms basically for network communication and compressing the data into transmittable states. So here we are in Themis, the basic concept is partial replication, which means we need to send only the necessary data to the cloud end. So how it happens? So this data synchronization under partial replicator architecture involves an algorithm where the block ID, which is the node ID or the car's ID, and the index is set. So for each operation it constructed, for example, applying a brake or moving towards fastly over an lane. So these kind of operations were converted into data. So that data is repeatedly connected through WebSocket and repeatedly transmitted over the channel. So each operation is compressed into a single snapshot of operation. So it will be transmitted over the network channel over a set of period of time. That interval, over the period of interval, this loop runs, and for each loop it creates a block ID and it sends the data towards the cloud system. So if you can see this process operation data package, it shares over the operation index, which is the series of operation over an interval, is sent towards the compressed in this particular process and transmitted over the network channel. So in the below channel, you can see there is a synchronized operation where they add and delete nodes over an system, which means there will be multiple receiving of data packets from different nodes. So whenever a new node sends a data, the data will be read and processed, and then it will be deleted. The deleted node will be synchronized with the cloud server nodes. So this is how the synchronization and unsynchronization happens between this cloud system and the edge system. So once this process has happened, the synchronization request for the next operation, which means the edge node needs to send the next set of operations towards the cloud node. So based on this algorithm, it happens. Each block ID, again, each operation is compressed into a snapshot of operations. So once again, this will be looped under looped based on the overall snapshot it reached to transmit towards the cloud service. So over this process, there is an ratio of nearly without ATS, without address transform space. If you can see, there is like 748 percentage of bytes, 748 bytes is shared over a period of time. So this ratio is consecutively got higher after obtaining the ATS system in the distributed system. Also, the responsive time over responsive time over the replication ratio are also similar to what achieved in the existing system also. So as part of this particular theme system, the partial replication strategy was implemented successfully, and it also reduces the data transmission size, which is the main objective of this particular paper. And also it improves the real-time responsiveness between the cloud and the edge nodes, synchronizing with only relevant operation snapshots and confirming the effectiveness of this strategy. The snapshot strategy improves the system efficiency by minimizing the number of operations because the operation got compressed into small snapshots and shared over the network channel. So it is easy to sync between the systems. It also ensures the consistency between the uh, with the reduced transmission cost in between network in the network, and also the compression of consecutive operations, which is over the communication between the cloud and edge nodes, where further optimizes the system by reducing the transmission overhead while maintaining the causal consistency and ensuring the final state accuracy by confirming the effectiveness of the snapshot received over the cloud end. And also the response given back to the server end is able to process the next set of operations efficiently. So based on this paper, there is two questions which is important to distributed systems and algorithm, which is partial replication strategy. What is partial replication strategy? So another one is compression of consecutive operations. So that's all about the themis. Thank you.